Here we have screencast 5, which is the test corrections. Question number 1, I butchered up pretty bad. We were given the velocities and we were asked to find the position over time and acceleration over time. And from velocities to position, it's simply the integral of it, or the antiderivative. Antiderivative of a line, which is y equals x, is y equals x squared. That's why it's a half parabola shape. Such as this one right here. We've got a parabola facing down because we have a negative line. The velocity of a constant, or I should say the integral of a constant, is y equals x. For acceleration, we got to find the derivative of velocity to find acceleration. So the derivative of a line is just a constant, of y equals x is just a constant. Same thing as we have here. Derivative of a line is just a constant at this given constant. And the derivative of a constant is just 0, so there's no acceleration. That is problem number 1. Problem number 2 was a tangent vector question. We were asked to locate the position of a plumb bob being swung from left to right. The last one that I got wrong was part D, which was that the plumb bob was in the highest point on the right. What direction would it follow? And here's my tangent line here at the highest point. Initially I had it going straight up. After adjustments, it's actually coming off at a slight angle. Question 4. We were asked to find the average velocity vector of a plane that was heading from Springfield to Detroit. This was the magnitude, 310 miles per hour, of the first direction of 60 degrees. The second one was 195 miles per hour at a 30-degree angle of this. So here's, I found the velocity in the x direction in both of them, added them together, and this is the total. Here's the velocity vectors in the y direction, added them together, this is the total, 366. So I simply divided those by 2, each one of those vectors, and here's my resulting average I and j of 161.95 and 183. So I just basically took the square root of those numbers squared to get a final velocity vector of 244 miles per hour, with an average, with the direction of 48.5 degrees. Question number 6. We were asked to find an expression for velocity and the time at which the velocity is 0. This was the initial position we were given, so it's just set to 0, and it's just manipulating the numbers around, moving the numbers around a bit to where t would equal to root 2. Number 7. We were given a diagram with just a block, solid block going up an incline. We were asked to find the total forces on this block with a force, a push force, in the direction of the plane, the horizontal plane. Here's my coordinate system. Here's the sum of all forces equation, and after plugging in the numbers, if the push force was 100 newtons, we would have a final acceleration of 4.53 meters per second squared up the incline. The block would actually move. But if the magnitude was equal to the push force, simply wouldn't go anywhere. The crate would be still. And the crate would not move. In the last question, question number 8, we were asked to find the maximum speed the car can go without skidding in the roundabout. So here's my free body diagram. I got the force of newtons up, force of the weight down, and I got the force of static friction pointing in towards the circle. Should be a circle around this. So just basically following the example from the book, I took the coefficient of friction, of static friction, which is 0.535, times it by the gravitational force, which is 9.8 meters per second, and I times that by the radius of the roundabout, put that all under a square root, comes out to 14.48 meters per second, and in converted to miles per hour, I got 32.4 miles per hour is the maximum speed that the car could go around the roundabout without skidding.